Hi everyone, we're going to walk through Google Collaboratory notebook functionality and describe the types of things you can do with it and so on. It will be very extensive. I may repeat myself a few times, but hang on. Google Colab is basically a Jupyter notebook on steroids. It has similar functionality but backend in the cloud, so you don't have to have local computational power to compute Python or R script. It gives you a web-based interactive interface where each cell is executed cell by cell, and you can see the output. Before moving on to the next one, you can modify one cell and then re-execute everything below or above instead of executing the full Colab notebook, which is convenient. This functionality may also be observed in AWS or Amazon Web Services, SageMaker, Microsoft's Azure Notebook, and Wolfram Mathematica, among others. It's convenient to share this type of notebook with other individuals or collaborators because you can insert ideas or explanations in between your code or for the code results so that others can see. It's my understanding that in the past, you could simultaneously update the same document and it would be similar to Google Document or Google Sheet. But we discouraged from using the notebook this way because there is a delay in the updates. If multiple users are using a single notebook, then you may be overwriting each other's changes before you see them. Instead, you can make multiple copies of a single Colab. Each user would modify documentation, model, or pre-processing or whatever else with their copy of a Colab, and then have one person on a team to merge all the changes before submitting your document to our graders. The requirements are simple. You need to have an internet connection and a web browser to be able to view the Colab. But if you want to create, modify, edit, import, or run a Colab, you will need a little bit more. In your Google Drive, you'll need to install a Collaboratory plugin. It's easy. Go to your Google Drive, assuming you have a Google account, right-click on an empty space, go to More, and connect more apps. Once you search for Colab, Collaboratory will come up. Mine says installed, but yours may not. That's how you install it to your Google Drive. Once you do that, you will have Colab Notebooks folder where your Colabs will accumulate. If you make a copy of a Colab, it will likely appear, or if you import a Colab, it might actually go into this folder. If you made a copy of a Colab and you can't find it, look for this folder and see if your Colab notebook is in this directory. You can also right-click here, go to More, go to Google Colab, and that will create a copy of a blank Colab notebook that you can work with. Here at the top, you can change the name of your Colab document. It will immediately update after you save it in Google Drive. You can also import IPYNB files from Jupyter to Colab either by dragging and dropping them directly into your Google Drive, and they will be opened from that point on with a Colab plugin, or you can go to File and upload a notebook and select your IPYNB file to be uploaded. Likewise, you can export Colab to IPYNB files or Python coding files so that you can share that offline with your collaborators. We will discuss later ways to connect your Colab to your local Jupyter notebook server, so you would not have to export Colab into IPYNB file and open it separately. It'll be much easier than that. The layout is familiar if you have worked with Jupyter notebooks. You have two types of cells. One is the text cell, which uses HTML or Markdown or LaTeX and can display images. HTML is a rich markup language that uses tags to modify layouts, coloring, font sizes, and so on. Markdown is lightweight markup language without tags, so it's much easier to use, but has a limited functionality. The benefit is that you can read code as if it was a text. For instance, here it says this text cell uses text, does not have any text. It has two asterisks on both sides, indicating here on the right side in the preview that it needs to be in bold. It's still readable. Of course, if you add hyperlinks and tables, it may be less readable than you would probably want. But it's easy to write in Markdown, so definitely get a handle on this language if you still haven't. LaTeX is powerful and easy to use in Colab. All you have to do is put a $sign on either side of your expression or two $signs. We'll look at that later. Images are also easy to display. Either link to an image on the internet or copy and paste an image directly into your text cell. Coding cell allows you to interface with different interpreters. It could be Python or R, depending on what you specified in your runtime. Here we have Python 3. It could also be changed to R. You might also be able to connect it to some other interpreters like Ruby or C++. Bash is shell for Unix. You can write Unix commands like we have here, precede them with an exclamation sign, and it will run against local Unix environment that is allocated for your session. It's one way of interfacing the operating system's commands. Magic commands for a Python are quick interpreters. We have them here to time your code, profile your code, interface or manage your file system, and so on. Double % signs will give you a magic command that executes in a whole cell, and single % sign executes only per line. If I execute this line, only this line will be timed and we'll have an estimate of how long it took to run this line, but the first double % time will give you the overall time for this cell and the answer displayed below. Here we save an arithmetical expression result into English B, Greek beta, and Russian beta, but you can use other Unicode characters, and we're displaying beta. You can read more about magic commands. You can create your own by following this link. Exclamation sign will give us access to bash commands. You can write ls and we see sample data. That's a folder that is automatically created. Go to folders in this left sidebar. You will see that there is a sample data folder. Open it. There are some housing data files that people might work with. We'll show you how add and remove files from here later. You can also create and delete cells. When you drag a mouse between the cells, it gives you an option to either add a code cell or a text cell, which you can also do through here or through the menus. You can add code cell or text cell. And there's also a shortcut for you to add either one of these cells and change their type from one to another. Keyboard shortcuts are powerful time savers. Let's go over the menus. There are lots of menus here. You see the sidebar, you see the top bar, you see some drop-down menus here on the right-hand side. Every one of the cells has its own menu, and there are menus at the top. We'll start with this, top menus. By going to File, you can locate where your Colab document is located. Locate in Drive. You can also open it in Playground mode, which will create a copy of your Colab that will not be saved. You can modify cells, play, and change your Playground Colab in many ways, but none of those changes will be saved, which is convenient in some situations. You can create a new notebook in Drive. My guess it will be created in that special folder Colab Notebooks. You can open a notebook and so on. Rename it, but you can rename it directly at the top. Save a copy in Drive, and that's if you open somebody else's Colab for viewing, you can make yourself a copy by saving a copy in Drive, in a GitHub, and so on. You can also download a copy of your Colab as one of these two formats, IPYNB or PI. You can print it to PDF, but it will probably truncate and cut out some of your images. It may or may not work, but what's also cool is that you can look at your revisions. It's a Git built into your Colab. You can see everything you've done since you've started the Colab copy. If anybody modified this Colab, it will be reflected here. You can name your changes. Go to the menu, click name this version. You can compare one version to another on the left and on the right and see the changes that were made in this view. You can also open any older version in a separate browser tab, work with it and copy the code lines that you think were removed back into your current version, or you can revert any of the old version. Basically, anything that you would expect from revision history manipulations. If we go to Edit menu, you can insert cells, copy cells, all that is standard, but there is Notebook settings. You will see this several times. It's the same settings that appear with an exception of perhaps these two options. Here, choose a different language, and free version of Colab gives you this computing resources, 2 logical CPUs. They're cheap, inexpensive, shared by other users, but they're free to access. There is a T4 GPU. You won't need T4 GPU unless you know your model can take advantage of it. But if it can, the model can train or make inference predictions up to 100 times fast. And you will see it in some competitions later in this course. T4 has about 2,500 basic CUDA cores, and it has several hundred tensor cores. You can look up its specifications to be familiar with its capabilities. TPU will need separate Python code running to access the power of TPU, but it can also speed up your computation a couple of folds. Clear all outputs will wipe out all outputs, which you can save with your Colab. So if you go to notebook settings again, you can force to remove all output from cells. That will shrink the size size of your Colab significantly if you have lots of images or plots displayed. In the view menu, you have table of contents, which is the same as this sandwich icon here. You have notebook information about the user and the notebook size, which is helpful if the notebook gets larger because of the outputs. You may want to control that. Executed codes, history, comments. We will review some of this. If you go to insert, you can insert different types of cells. Scratch code cell, which is convenient. As you're working in a Colab, you may want to display your variable. You don't need to create extra cells and then delete them later. You can just open a scratch cell, run B as we have here to see the contents of B. Once we close the scratch cell, that will go away. You can have multiple scratch cells if you need to. Code snippets are also helpful. You have code snippets for different languages, for different scenarios. Along with that, you have Gemini, which is AIs that can give you additional code examples. If we look at the runtime menu, it has run all, which will run from top to bottom every one of your cells, including the text cells. This is helpful to debug your code. We want you to run your code from top to bottom in a clean environment with no additional packages installed, so that your code does all the installation, all the imports, all the variable definitions, function definitions. You can see this way whether there are errors in this process before you submit your code to the graders. The graders will be doing the same thing. They'll be running your code from top to bottom, and you want to make sure they do not encounter any errors. You can run a particular selection. You can run up to a certain cell or after a certain cell. This is helpful on some occasions. You can interrupt lengthy executions, restart your session. This will clear the variables. It will clear imported packages, but it will not uninstall packages that you installed during a session. It will also not wipe out the files that you brought in. This is helpful because it's a fast reset, but you may want to disconnect and delete runtime if you want to thoroughly check the functionality of your Colab. Disconnect and delete runtime will basically wipe out the whole session, all the temporary files that you brought into this files root directory. It will remove all the packages that you installed. When you run your notebook after deletion of runtime again, it will clean a brand new copy of Colab's environment with all the standard packages that Google provides. That's when your code will start running again and installing the packages, importing them, bringing the files in, processing the files, and creating the outputs that you desire. You want to make sure that there are no errors in between. We recommend you disconnect and delete runtime before you submit your code to us so that it runs errorlessly. Change runtime type will again open this window where you can select either the computing resources or language to run against. Manage sessions will indicate how many sessions you have running currently. Sometimes you will see error that you have too many sessions, you need to kill some. This is where you can kill them. You can terminate everything except the current session, or you can terminate each one individually. You have basic information on Colab that runs here, and we'll give you some tricks on how to overcome the limitation of the compute resources that Google places on you. The GPU resource is also constrained. Sometimes you will see error messages that GPU cannot be allocated for your session. Do you want to run without a GPU? If your code does not use GPU, sure, use CPU. But if your code needs to use GPU, your model is trained with GPU much faster, and you want to fit within the runtime limits that we allocate, then you will need to think about additional Google accounts and different setups that we'll discuss a bit later. View resources will show you your current resources in Google Cloud. It may not show you what you currently have on a local PC if your Colab connects to your local PC. So here we have almost 13 gigabytes of RAM, disk space of about 100 gigabytes, Python 3, and some other information. Look at runtime logs. I don't use that, but it may be helpful. Look at tools. Command Palette gives you searching capability for different commands accessible to you via Colab. There's also settings, which is a way to slightly modify your environment, make it darker, change the wraparound threshold on text, and so on. Do look at this to get familiar with functionality you have at your fingertips. Keyboard shortcuts are helpful. There are shortcuts that are predefined. You can also define your own by clicking on the keyboard combination. You can open cells, close cells, delete cells, move content around the Colab with a click of a button or two, and that makes everything faster and less frustrating. You can also look at differences in notebooks if you want to. Help is powerful in locating additional resources. Now let's look at left sidebar. We have more icons here on the left. The first one is just a table of contents. sense. If you are using Markdown and headers within Markdown, as we do here, there are hashtags or pound signs indicating the level of a particular header. It will appear here in the level indicated. This is helpful for quick navigation around your document. Search and replace allows you to use regex or regular expressions to find more complex combinations of text or letters. You can also look at your variables by clicking this X in brackets, and it will display the variables you have created, their type, their shape. If they're a NumPy or pandas, they might have a shape, and their value is displayed here as well. You can filter by variables and so on. Secrets allows you to add persistent encrypted keys or API tokens so that when you share your Colab, the other user under your authentication can access certain resources but does not have access to your login information. You might use it in the future, but for now, this is just a nice feature that you can explore on your own. File panel is where you will see files accumulating brought in by Kaggle API from a particular competition. When we run a baseline code, it might generate some additional files here. From this area, you might want to download files to your local PC before you upload them to Kaggle. There's also a way to upload data to Kaggle automatically, but we'll discuss that later. This is the place where you drop your Kaggle.json so that Kaggle API finds your authentication. Then you have code snippets again, command palette, and this inaccessible command line interface. If you purchase a subscription, you can use that, but you can put an exclamation sign before your bash commands and execute them that way. Let's look at the top bar. You can add comments to any cell. If you're looking at somebody else's work and you want to leave a comment or have a conversation, you can just click on the cell, then click on the comment icon and add a comment. Hey, how does this work? You would leave a comment for somebody else to reply. You can also click on the settings, and we've seen this before. There are a couple of options you can explore. Share button is important because you will submit your Colab notebook URL links to Canvas LMS, Learning Management System, and you need to enable anyone with the link to have access to your Colab to be able to run it. So change general access to anyone with the link, copy a link, that's what you submit to Canvas. Now this Colab becomes usable and viewable and copyable by other people with that URL. Make sure that you take that URL into an anonymous or in private browser and open it so you can see it opens for anyone having the link. If you forget something in the process, it may not open, we may not be able to grade your work, and we'll need to deduct points for late submission. Also, run it from top to bottom so that there are no errors in the process. This will speed up our grading, and it will also make sure that you're earning maximal points for your work. Last ran cell. This icon will focus or scroll up or down to whichever code cell you ran last, which is convenient. So you may be dealing with a long document, you may scroll all the way down. By clicking this check mark, you will jump back up to the cells that you ran last. This icon will tell you the resources. We've seen that before. It's RAM and disk, but also which Python version you're running. This drop-down gives you several options on what computational power is supporting your Colab. It could connect to a hosted runtime, which is what we're using right now. You could also connect to a custom Google Cloud Engine or Google Cloud Platform, GCP, virtual machine. That's a paid environment. I don't think they have free ones. However, you have connect to a local runtime, and this is valuable. If you click on this, there is some information, and there's a URL that you need to provide in here to indicate where your Jupyter server is running. I can start Jupyter server right now, copy its URL, and paste in that box to have more powerful resources. This is Jupyter in the web browser. I can double click on Maxima, which is another computer algebra system. Yes, it opens up, so my Jupyter is running. If I go back to CLI, now this is a bit skewed, but there is a line here which is localhost 8888, and there's a cryptic token. I copy that token. That's the token that brought me to that Jupyter site. I can paste it here. It ends with 0C. I'll just make a note of that, and it opens up the tree. Now, if you haven't worked much with Jupyter Notebook, I highly recommend it. It's another great tool, and you can do a lot in it. You can can create additional Jupyter Notebook files. You can run your Python code or other interpreters code in Jupyter. However, we needed that URL for one purpose, to paste it here, it's ending with 0C, and make it available to our Colab. If I now run this cell, it will be running against my local server. Now, all times are 0 nanoseconds, and that's because my local server is much more powerful than Google Colab is offering. We'll review more of it later, but this is one way to connect to your local resources. You can connect to GCE, you can connect to local runtime. Google offers 2 CPUs, a GPU or a TPU. The CPUs will always be there, but you might also have a GPU or a TPU for specific tasks, such as training on GPU or TPU. It offers 13 gigabytes of RAM, so if your local system has more, great, you can use that. Whatever backend system computing power you use, make sure that before you submit your Colab's URL to us for grading, it runs in free Colab environment without any errors. Your local interpreter might have a different setup, packages, environment, directory structure. If you don't test your code in a free Colab environment, it will crash, it will give error messages, and we will have to deduct points for late submission after you will have fixed the notebook. You can experiment faster with local resources or some paid resources. You can have multiple free Colab notebooks open in parallel and experiment faster that way. It all comes down as a funnel to just one submission where your Colab notebook works in a free Colab environment. Gemini AI is this icon here. It's a great way to get code snippets or answers to your questions. For instance, I can ask, what resources does free Colab have? It'll tell me that it has up to 12 hours, 2 virtual CPUs, GPU of a particular type, and so on. I can also ask, what is LaTeX formula for Gaussian PDF? It will print the LaTeX formulas that I can copy and paste into my code. Here it is. You can also ask for a Python code. What is Python code to filter pandas on index? And it gives me a code I can adapt to my work. Gemini also allows you to create a code snippet. Click on generate, where you can ask the same question. Click on generate, and it will create a sample that you can adapt to your work. There's a pandas import, data columns with values, there's some sort of range dates in the index, and then there is a filtration on start date and end date. I can close this and I can reuse this code as I want to. If it's just a small code snippet, you don't have to cite it, but if it's a key idea in your work, we'll ask you to practice citing your sources. We can delete this. The cells have functionality as well. There are options to move it up or down. Copy link to cell, useful when you communicate to others a question about your Colab. You can reference this cell by clicking its URL. And if I paste it here, it's a very long URL identifying exactly the cell I copied it from. You can also leave a comment for this particular cell and some other functionality, including removing it. If you are editing it, you have an additional bar with markdown options. There is heading toggling, bold or italicized. You can format as code, you can insert images. We recommend that you just remember these commands. They're easy, but if you do forget, they're all here. There's a little bit of LaTeX, emojis, and so on. Documentation in Colab can be done in a variety of ways. LaTeX is accessible to you for mathematical expressions. Do use it because it makes it easier for you to communicate your thoughts, your ideas to somebody else. Symbolism is compact and precise. You can do an inline formula with a single $sign on each side of the expression, or you can do what's called a block formula for between the paragraphs, where the paragraphs are moved out and your formula is in the middle, as it's shown here, with the double $signs. You can also define macros in LaTeX with new command. Look it up if you haven't seen this before. Formulas can be quite sophisticated, but they're easier to parse out into smaller elements, such as coloring, different components, and then combine those components together. If we look at this code, we have new command for color silver. Anything that is passed to this command will be colored in silver. We have a command for bracing. This brace right here uses this command with the coloring. There's a constant command, and that's for this constant right here. The first formula lacks this constant. It only shows the density, which is a separate command. So this density right here is in both formulas. And inline has f of x, as it is here, equals or proportional to density, which is the command we defined. So proportional to this symbol, almost like an infinity symbol cut off on the right, the density. The macros are very convenient. LaTeX cannot install packages, so you cannot use TXZ for drawing images. It would be great, but you can draw boxes and you can color a LaTeX code, so you can do some diagrams as we demonstrate in some of the Colabs we release in the class following the HOML or HOML textbook. Reinforcement Learning Colab has lots of these boxes and diagrams based on matrices. I'm not going to read this comparison between HTML and Markdown. It's generated by DeepSeek R1 model. Read some differences, such as HTML looks more complex. It allows more flexibility in layout and coloring and font sizing and so on. Markdown is much simpler, readable. For our class, Markdown is all you need. Difference in complexities, in features, some use cases, rendering, set of examples. There's a summary of how they differ. And then we move on to images. Images can be linked from the internet using either Markdown or HTML. If it's HTML, then it's image tag. You indicate the size, which you cannot do in Markdown, the source, the alternate text, which is always preferred. You can see how the Markdown images are linked as well. This image is from Wikimedia. It's a free image, and be mindful what images you use. For commercial purposes, the constraints are significant. You can't just use any image for the business where you're making money. Wikipedia images are mostly Creative Commons license, which typically allow you to use those images in any environment, such as academic or business. This image is a copy and paste of the image itself. If you print screen an image and paste it here, it will have the Markdown image tagging, and the address will be just the data. All this cryptic information is hexadecimal pixel coloring for the image. So you can't control the size or the placement, but it is sometimes convenient. This image is also heavier because it has all that code saved in text cell. Computing in Colab. Here is a comparison between Colab and Jupyter. Again, it's generated by DeepSeek R1 LLM model, and you can read it on your own. The big difference is that Jupyter Notebook typically uses your local resources, and Colab uses Google's cloud platform that you can launch on demand at any time. There are multiple interpreters in Colab. Python and R, what we have already seen, can process data, manage files, build visualizations. Sometimes that would require more code than necessary. You might refer to Unix kernels to install packages or manage files or bring in scripts. It's oftentimes more convenient. Use exclamation sign and Unix command, let's say pip, that needs to be pre-installed, of course, to install, upgrade, or downgrade an NumPy package. IPython kernel would process your magic commands that have %signs. We talked about that before. There is a command called timelit instead of time that will run your code 100,000 times or so. Be careful with this command. It has a parameter n that allows you to set number of times to run your code. If you want some sort of average runtime for a particular line or some more detailed profiling, but it may be too long. The %bash would take the full contents of your cell as the bash command. Colab computing resources. You can look at Colab's FAQ. They're somewhat vague about what resources are allocated, but typically your Colab will run for up to 12 hours, and it would depend on availability and your usage patterns. There are 2 virtual CPUs that's more or less stable. The GPUs and the disk space tend to vary. I've seen 30 gigabytes and 100 gigabytes, and it may depend on your Google account and other uses of it. 13 gigabyte RAM was fairly stable over years. In the past, K80 GPU was offered, but now it's T4 GPU. It has about 2,500 CUDA cores. They're very simple processing units, but they can do amazing matrix computations. When the whole matrix needs to be computed faster, computations are simple, just additions and multiplications. It has about 320 tensor cores, which are more powerful for tensor computations. It has 16 gigabytes of memory, and there's some bandwidth. You can actually get more details if you ask Gemini. We looked at the ls Unix command. There is line 1, which allows you to output multiple results from a single cell. Second line imports the operating systems package and PSUtil package to check the resources in our Colab. This cell printed virtual CPU and physical CPU count and RAM. It reflected 2 CPUs for the Google Colab. Right now, we are connected to the local computers that I have here. If we execute this, we see 64 logical, 32 physical CPUs, 2 threads per physical CPU, 128 GB of RAM, and other details. So if I switch back to connected hosted runtime, these numbers will drop and my experiments will be slower. You want to control between what you experiment by yourself versus what you export to the teaching team for grading. This command will give you more information on the CPU, details that I don't care for. We can suppress or hide or clear this output. This line will load TensorFlow, which may or may not be available on your local computer. And it will tell me the device name or the GPUs that I have on my computer. Right now, it's apparently nothing. NVIDIA SMI will give me information. GeForce RTX 2080 is the GPUs that I have locally. If I switch back to connect hosted runtime, I would need to reload my packages. Otherwise, some of the Python functions will not run. I just switched to a different environment, and I'm not sure if the Colab environment is still running and I can still reconnect to a running environment. NVIDIA SMI tells me that it's not available, and that's because I switched the runtime from GPU to CPU. If I switch back, this is in the cloud. If I switch back to GPU, click OK, it may not allow me to. It did not allow me to do that before. Let's try it. Yeah, connect without GPU. I can't connect with GPU right now. Tomorrow it will reset likely, and I can start reusing it, or I can go to the incognita window, log in under different Gmail account, open the same Colab or make a copy of it and modify and work with that Colab with GPU resource accessible to me. Let's still execute this line to see that we're back to our resources of the Google Cloud Platform. That's all for now. It's a lengthy video, but hopefully it's helpful to you and you can squeeze most power from Google Colab.